list of textbooks, you'll see an Oxford statistics book. Pages 69 to 71 of that book do a really good job of explaining the central limit theorem. So I encourage you to go there and read what they've said. The basic idea of the central limit theorem is that no matter what type of distribution we have, if we take enough independent observations from it, our results of the X bar, the mean of those results, will mimic a normal distribution no matter what type of original distribution we had. But we have to take a large enough sample. So generally we define large enough to be n greater than 30, and then we can apply the central limit theorem. So if we have something happen more than 30 times, we're looking at an average over more than 30 days, like we are down here, something like that, we take a sample bigger than 30, we can apply the central limit theorem to say that because we've taken a large enough sample, our X bar is going to be normally distributed with the same mean and variance over the size of the sample that we took. So just like if we took a bunch of linear combinations of a normally distributed variable. So this is like what we said before, but now we're saying that X is any distribution that has a mean of mu and a variance of standard deviation squared, which is always true. So sum of the mean is n times mean, n times standard deviation squared, and here's our X bar. So SMA eats on average 1900 kilocalories per day. So my mean is 1900. Standard deviation, so sigma is 400. So that means sigma squared is going to be 160,000. So what is the probability that in a 31-day month she eats more than 2,000 calories per day? So I want the probability that X is greater than 2,000. I'm going to say that because I have 31 days, my X bar is going to be a normal distribution with mean of 1900 and variance of 400 squared divided by 31. So now I can go ahead and find my probability with those numbers. Oops. All right, so my lower now is going to be 1900, upper 10 to the 10, 1900. Oh, sorry, I wanted her to eat more than 2,000. So it should be less than 50% because her average is 1900. And my standard deviation then is going to be 400 over the square root of 31. Because my variance had 31 in it, square root this whole thing, I'll get 400 over root 31. The probability is just over 8%. To 3 significant figures.